So hi everyone. Thanks all so much for being here. I see a lot of familiar names, so that's great. We're looking forward to providing this training for all of you on the RIDOT Road Stream Crossing Design Manual. So I've linked where you can find the most recent version of the PDF in the chat box with an explanation on how to find it. That's where you'll be able to find the most recent version at all times that's updated. There's actually some small updates being made now, so that version will be up soon. And you can also find the assessment handbook there as well. So if you have any trouble finding it, just reach out to us and we'll help you. So before we begin, I'd like to let everyone know or ask you to put yourselves on mute. And I ask that as we start presenting, you turn your video off, and that's just to improve our connection. So I'd also like to note that this meeting will be recorded and made available for everybody along with the slides, and we'll try and put those up on the contractor and consultants page as well. We'll have time at the end of the presentation for questions and discussion. If you do have any immediate comments or questions, you can leave them in the chat box, and we'll go over them during the discussion period. So we'll do some short introductions first. So my name is Nicole Lineberry. I'm a senior environmental scientist in the Natural Resources Unit at RIDOT. I was part of the team that worked on the development of the RIDOT Road Stream Crossing Assessment Handbook. And this design manual was always something we knew we needed as a next step, so that we are really excited to finally implement these design standards. And we'd really like to continue to work towards improving resiliency and aquatic connectivity in Rhode Island. So I'll let the rest of the team introduce themselves. Elisa, if you want to go next.
I'm Elisa Richardson. I'm the acting administrator of the environmental division, and just want to thank this great team, Nicole and Anik, and everyone who's really worked hard. Mark, who's worked hard, manual, and put all their thoughts and efforts in understanding of what is going to be expected of the consultants here. We do have with the infrastructure funding, they haven't really actually allocated it completely, but there are some protect funds and resiliency funds. We believe that this culvert design manual goes a long ways towards resiliency for Rhode Island. And so as we move forward, we're going to be asking that there is, we're going to try to get ahead of the projects that are coming up in the tip, and coming to project management for scoping. And we're going to try to start assessing those for the standards to see how they meet the base standards. And ideally, we'd like to bring them up to the base standards. And if that's the case, we're going to be advocating with planning to insert more funding, more funds into the projects and a little more time. These, bridge replacements and that includes culverts of larger than 5 feet, but also maybe any major culverts on blue streams. So, we're looking this summer to put together something, a contract to get those assessments out, get ahead of the tip, so that when you're assigned a project, you'll be able to maybe have an idea of this is what's going to be expected, that there'll be some sort of an upgrade, and that that this handbook will need to be applied. So thank you, and on to Nick. Or I don't know if Mark's here today. It's Mark.
I don't even know if I sent it to him because of everything.
Okay.
Yeah.
Okay, so Anik, go ahead. VHB, thank you.
Thanks, Lisa. My name is Anik Flora. I am with VHB, a water resource engineer and the project manager who worked with Nicole and Elisa to put together this manual. So we've been working for the past year and a half, reviewing the regional standards, other state standards, and the best practices throughout the country for stream crossing standards. And I think we've put together a pretty holistic standard manual for people to use to design stream crossings throughout the state. And then my team also includes Ariana Wetzel from VHB as well, and she's online today and will help answer any questions as we go through the standards and discussion. Nicole, you want to get started?
Yeah. I don't know if you were sharing. Did you want to share the presentation or?
Yes. Yeah.
Okay.
I can share. Okay, so road stream crossing manual design training. So for a little background, Rhode Island has approximately 3,500 miles of riverine ecosystems with about 4,300 road and railroad crossings over those streams and rivers. As currently in place, many of the crossings do have issues with flooding, sediment movement with scour, and issues with wildlife crossing and aquatic organism crossing. And those issues end up causing clogging, high velocities, perch culverts, and many things we've all seen before. So the purpose of this manual is to improve those conditions and provide specific standards for RIDOT-owned road stream crossings. And the manual is strongly encouraged to be used for other state agencies, municipalities, or regulators, though it's not required. So this is only required for RIDOT-owned road stream crossings. And the hope of the manual is also to avoid in-kind replacements with a more holistic approach with the acknowledgement and consideration of aquatic organism passage, stream continuity, hopefully providing a safer and long-term cost-effective approach, and we'll end up with more resilient crossings throughout the future. The development of the manual over the past year and a half, our team at VHB, working closely with Nicole and Elisa, have reviewed over 30 documents for industry standards, other state guidance, other studies for stream crossing throughout the country. We held 3 stakeholder meetings with various state agencies and stakeholder groups who are interested in crossings throughout the state, and took all of their input and hopefully came up with a design that will provide what everyone is looking for. So the manual is effective now, as Nicole mentioned, and is available on the website. There will be some minor updates. I've included some of the updates in this presentation, but not all of them. We've been working with another consultant that has started to use the manual for a current project, and we've gotten some good feedback on the manual. It hasn't changed any of the standards or the requirements, really just the presentation for deliverables. So those updates will come hopefully in the next week and a half, 2 weeks, with some back and forth between us and RIDOT. But like I said, it won't change anything that we see here today. So for new crossings, this manual is very straightforward. However, for the more common replacement and retrofit crossings, the ideal path that those crossings will take in a perfect world are RIDOT already currently has a 2019 Stream Assessment Handbook, which provides a rating system for the existing crossings. So the first step of a replacement or retrofit crossing would be to assess that crossing with the Stream Assessment Handbook, obtain a score for the various categories for that crossing, and then you have existing scores. So step 2 would be to now use this manual, the 2022 manual, and design a new crossing based on these standards, and then reassess that new proposed design using the assessment handbook. So that way you end up with Stream Assessment Handbook scores for the existing, and then Stream Assessment Handbook scores for the proposed. So that way it's really easy to say we've improved this crossing using the design standard manual. Obviously, it's not going to be realistic for every single crossing in terms of schedule and cost and the many other things that go into a design. But in a perfect world, that's where you will go from A to B. And then this design manual also will hopefully provide a pathway for emergency replacement projects so that we are avoiding more in-kind replacements when we have to move quickly. So as we put together this manual, we tried to focus on 5 key methods. First, as I already discussed, we wanted to build upon the existing RIDOT assessment handbook. So hopefully we'll be using, in conjunction with the assessment handbook, as you go through the manual, you'll see different sections and standards that refer back to the assessment handbook scores. So there's guidance if you've received score X in assessment handbook category A, then take this path to move forward on the standards. Second, the design framework, we wanted to use all the best standards from the New England region and throughout the country. So making sure we are acknowledging the good work that's already been done and taking the best from all of those. Third is structural and design considerations. So although this is certainly not a replacement for any other manuals, as I'll go over in a minute, we wanted to acknowledge that as you're doing your stream crossing design from a hydraulic and water resources point of view, you need to be working in conjunction with structural and environmental and wetland considerations. So at the end of this manual, we do provide conceptual prototypes, and those will be really useful for interacting and communicating with your structural design team and providing the key information that the two teams usually need to communicate together. Next is the base requirements for RIDOT highway functional classification. So there's already functional classification system throughout the state for all RIDOT roadways. So we wanted to use that as a base for our requirements. So you can start out with your functional classification, which I'll have examples for in a little bit. But for example, local road, you can start with that and then use that to find what your base standards will be for your stream crossing. And then last, we wanted to provide some retrofit guidance because we know that when it comes down to all the different considerations we have to think about in these designs, sometimes retrofit is the best way to go. So we wanted to provide some guidance on how to best approach that and when is the appropriate time to retrofit rather than replace. So what this manual is not, it is not a replacement for any other manuals that are out there right now. It is brand new, stand on its own, stream crossing design guidance as it is. It is not a replacement for current drainage manuals. It's not a replacement for bridge inspection, linear stormwater, anything else that's out there. You still need to go through your structures team and your LFRD requirements, as well as RIDEM permitting and any FEMA floodplain management or analysis requirements. So as I go through the design manual criteria and standards, I want to make a distinction between the design standards and the design criteria. The design standards are referring to the optimal level and the base standard. So there are 12 different design criteria, and you can either meet the optimal standard or you can meet the base standard for that design criteria. The optimal standard is in a perfect world. You'll meet optimal for all 12 design criteria and you'll pass with flying colors. However, we understand that there's lots of different situations out there and we may need to drop down to the base standard. However, in order to do that, you will need to communicate with your RIDOT team, that being Elisa and Nicole and their department, and get their approval in order to drop down to the base standard. So these standards are all based upon the stream simulation design from the U.S. Forest Service. So that's something we're probably, most of us are all familiar with in stream design. It's a 2008 document with the goal of mimicking the characteristics of the National Stream Channel in as many ways as possible. So these are the two standards that I was discussing, basically on where and when it's appropriate to meet the optimal standard or the base standard. So you can kind of use this flow chart for anytime you're trying to decide whether you can stick with the optimal standard or drop to the base standard for each design criteria. So if I'm working with a replacement crossing, I'll look at the design criteria. So for example, we all are pretty familiar with the bank full width requirement for stream crossings. So you want to aim to provide for hours, it happens to be 1.2 times the bank full width with wildlife crossings provided on either side. And we'll go over that specific in a minute. But if you're able to do that, then great, you meet the optimal standard, no problem. If you're not able to do that, then you want to drop down, communicate with Nicole and Elisa, talk about why you don't think it's feasible, what obstacles you have, and then if you're able to meet the base standards, great. Now you're done with that one, move on to next. If you're not, then you need to discuss with Nicole and Elisa again, and you drop down to max extent practicable. So just a nice way to think about meeting each design criteria and whether it's base or optimal. So here are the 12 design criteria that I was referring to. And we're going to go through each of these and discuss the base and the optimal and how to meet each of those, and a little background on both. Every single one of these design criteria has a nice long descriptive section in the manual. So these quick presentation slides that I'm showing you are not the full extent. There's definitely more detail and specifics within the manual to go over, hopefully most design situations that we'll come across. So first is just the design approach. So this is more big picture. And as I said, the manual does use the U.S. Streamforest simulation approach, but there are other general approaches for stream crossing standards or meeting stream crossing standards, and those are aquatic organism passage design and modified hydraulic design. So this is a good way to start out your project and just discuss with RIDOT, hey, this is how we're going to think about the crossing moving forward. Second design criteria is the structure type. So the optimal standard essentially is any crossing that does not have a bottom. So a bridge, three-sided box culvert, open bottom arch culverts. So that way your stream is not being inhibited from a vertical perspective. Base standard with RIDOT approval is a pipe culvert, a box culvert, anything that's closed on the bottom, and then that's with embedment as well. And we have another embedment standard that I'll go over for criteria. Third is channel velocity. So the optimal standard for channel velocity is a velocity within a swimmable range of your aquatic organism target species, or a comparable reference reach if you don't have a aquatic organism target species. And that's a velocity when you're at bank full flow, and a range of base flows if you have no target species. So this obviously you would also need to include an aquatic organism study for that target species if you have one. And then the base standard is velocity at a comparable natural channel reach at bank full flow. So design criteria 4 is climate change. So this one is probably going to be more complicated than you're used to seeing. So I'll ask you to definitely pay attention here. I'm going to read this example. I think it kind of wholly encompasses what we're aiming for here, and then I'll go through the table a little bit. So this is all based upon the highway functional classification system, and that's how you determine your design storm, which we're all used to, your freeboard requirement, your design scour check, and what we've added here that's new is the climate check storm. So the climate check storm is intended for situations where we do not have projected climate change precipitation or sea level rise for your specific crossing area. So right now, as we've currently researched, there's no precipitation projections for climate change for Rhode Island. So that's why we developed this climate check storm. For sea level rise, there's lots of different projections out there. And as part of the manual we discussed, we'd like you to use the most applicable projections for your project, for your location. We understand that it's a very quickly changing science, and we have recommendations on the projection sources that we think are reputable out there, but we want you to choose those that are the most realistic for your site. So here's the example. If a crossing is a 15-foot span on a rural major collector, so let's just start out slowly. We have number one, span is 10 to 20 feet, so we fall within this category here. And then we're a rural major collector, so we're going to be within this row here. It's a planned construction year of 2025 with a service life of 75. So that means that its climate change projection horizon is 25 years. So when you're thinking about climate change, you're going to project out to 2025 plus 75 years. The designer must find the most applicable and up-to-date sea level rise and precipitation projections for 2100. So that's your climate change current construction year plus your 75 years of design life. And so your design must pass the 2100 4% AEP tidal event if it's tidally influenced, and the 2100 4% AEP precipitation event. So there's the if projections are not available, the climate check event is utilized. If projections are available, let's say in 3 years, somebody comes out with precipitation projections for Rhode Island that go out to 2100, then you don't need to worry about the climate check storm, and you're just going to use your design storm in 2100. So the 4% AEP storm in 2100, we pass it, great. We are good to go on the climate change criteria. So write down any questions that you might have about this. I know it's new. This section is very well detailed in the manual, and hopefully an example like this gets you to where you need to be. Design criteria 5 is the crossing profile. So the optimal standard is that the crossing profile will match the existing natural stream using a reference reach and the vertical adjustment profile. The vertical adjustment profile will be familiar to those of you who are familiar with the U.S. Forest Stream Simulation approach. This is an example of what a vertical adjustment profile will look like. And essentially, it helps make sure that the stream embedment and the profile are consistent with the historical vertical movement of the stream. And the base standard is that the crossing profile will match the existing natural stream grade upstream and downstream of the crossing location. Design criteria number 6 is the embedment, substrate, and channel stability standard or criteria. The optimal standard here is for open bottom structures to have at least 1 foot of natural substrate material above any required scour protection material. This standard also requires you to include a scour stability analysis, as you would need to know where your scour protection material is, grain size analysis, and then both the optimal and base standard require you to mimic the crossing design low flow depth and natural channel. So here's your standard 5-point channel, and you just want to make sure that you have that low flow channel to allow for aquatic organism passage and lower flows and matching velocities of the natural channel. So if you're unable to meet the optimal standard, let's say you have a closed bottom culvert, then you automatically end up in the base standard category. For closed bottom culverts crossings with spans greater than 8 feet, you must have a minimum embedment of 2 feet. For crossings less than 8 feet in span, you must have a minimum embedment of 25% of the opening height. So this one is a little bit more strict than others. However, with all the studies that are out there for it, we definitely wanted to aim for the best here. And especially with crossings that are smaller than 8 feet, those are the ones that you really have issues with washout and then aquatic organism passage issues and all the things that come with that. Design criteria 7 is hydraulic modeling. So most of you are probably familiar with HEC-RAS. That's going to be our optimal standard. And then your base standard will be H/8, Culvert Master, HydroCAD, or equivalent. And for both of these standards, you can discuss with RIDOT if your program is not listed, and just to talk with them about whether your equivalent software falls into the optimal or to the base standard. Or design criteria number 8, openness ratio. The optimal standard is your openness ratio will be equal to 1.6 feet and your height will be greater than 6 feet. And if your conditions if you happen to be aware that this current culvert or existing culvert significantly inhibits wildlife. So for example, if there's a lot of wildlife car crashes in this area, then you might want to then we recommend using a greater openness ratio of 2.6 feet or greater. And if anybody doesn't remember what openness ratio is, it is the cross-sectional area of the culvert divided by the length of the culvert. Then the base standard is if your openness ratio is greater than 0.82 feet or to the maximum extent practical. Number 9, the stream crossing span. This is the one that I mentioned in the example before. So for the optimal standard, we require a bank full width times 1.2 or greater. And that also would have to include banks on either side of the crossing, within the crossing, that are specifically designed for wildlife passage, terrestrial wildlife passage. And that also includes thinking about the profile of your banks and making sure that you have a consistent grade from outside the culvert to inside the culvert so that any critters can cross from one side of the culvert to the other without much issue. And then the base standard is just the hydraulic span times 1.2 bank full width with banks on either side of the crossing, on either side of the stream, but don't necessarily need to be designed for wildlife passage. This section of the manual also includes guidance for aligning your crossing with the stream relative to the stream alignment. So that's where you start thinking about skew and the best way to cross the stream for whether or not it's a shorter span of the bridge or wider or whatever the many different variables that go into your design are. Design criteria 10, this is kind of a gimme. Make sure that you have a structurally stable crossing, so you're communicating with your structure team, you LFRD bridge design, you're meeting the current RIDOT bridge design manual. Design criteria 11 is the coastal tidal and coastal modeling. So obviously this is not required for crossings that are not tidally influenced. So to meet the tidal standard, if you do have a tidally influenced crossing, the optimal standard is that your velocity should be comparable to the natural stream channel during the ebb and flow for high tide or maximum flow conditions and for low tide or low flow conditions. So your max flow condition might not be at high or low tide. It actually is probably more likely that it's during the exchange from high to low. And to meet the optimal standard, you need to do that by using a detailed unsteady hydraulic modeling analysis. So HEC-RAS will do this for you if you're able to use an unsteady model. And this should also include aquatic organism passage. So during those max flow conditions, you want to make sure that your target species is able to move through the crossing when necessary, and that the aquatic organism study requirements are further detailed within the manual. And then, as you would expect, any tidally influenced crossings must also consider the sea level rise in order to meet the climate change standard that I discussed earlier. And to meet the base standard for this criteria, the design must accommodate the exchange of the full tidal prism. And you can do this using a simplified quantitative analysis, just in Excel, showing the volume of water that's exchanged from high to low. I do want to note for this criteria, and it is further detailed in the manual as well, there's lots of different considerations when you are changing the size of a tidal culvert. So if it's currently undersized, especially, depending on what's upstream of that crossing, your crossing may be currently acting as flood control for tidally areas that may previously have been tidally influenced without that culvert. If the FEMA floodplain was drawn with that current culvert, changing the size or increasing the tidal exchange of that culvert could end up causing impacts to the FEMA floodplain. So that's something you're going to need to discuss with your design team at RIDOT, and it might be a reason for not changing the size of the culvert. Or if upstream of that culvert is lots of current freshwater marsh and we want to turn it back into coastal marsh, this might be a great restoration project for that. There's lots of considerations in terms of tidal culverts, and they're all hopefully discussed in the manual. Make sure you're thinking about them as you're moving forward with tidal culverts. And the last design criteria is the reporting requirements required for all crossings. And this is going to be a report that you will deliver to Nicole and Elisa's team at the 30% design submission. And so we have an example of a report that would meet the requirements at the end of the manual. And it includes two checklists and one design table that you'll fill out as part of your deliverable, and then also the concept figures that I mentioned earlier. And so if you're able to fill out these 4 things, then you're going to be in good shape. And then your report will be pretty straightforward: background, existing conditions, how did you get to proposed conditions, and then including any hydrologic and hydraulic computations that you did, as well as your geotech investigation. For the geotech investigation, we do also include some guidance on where you should be taking your samples and what you should be analyzing for. So these are the checklists that you're going to provide as your part of your deliverables. And essentially it goes through the 12 different design criteria and helps RIDOT understand where you met the optimal standard in this column and the base standard in this column. And you don't need to feel like you need to put all of your project information, who, what, why, when, and where on these checklists, because that's what your report is for at the end. It's to explain why maybe we ended up only using HY8 for our analysis and therefore we're meeting the base standards. Maybe it's a really straightforward crossing and you don't have very much budget. So this is just a quick view of your project, and then the report is where we're going to dive into the specific information. So we have it for existing conditions and then a very similar checklist for your proposed conditions. Same idea, the 12 different design criteria, and then whether you're meeting the optimal standard or the base standard. And then in this one, we also have the max extent practicable, because we understand that we're not going to be able to meet all the standards all the time. Then the third table is your hydraulic design table. So this is the information for your final design, quick grab information for the structures team, for your environmental team, where your crossing is, the background information. Are you in the FEMA floodway? Is that something we need to think about? And then your crossing geometry and your hydraulic design requirements, whether you're meeting freeboard what your design storm elevation was under existing conditions, what it is now, scour, climate check, and then a tidal section and sea level rise section if that is applicable for your crossing. So these are the conceptual design figures that I mentioned. These are available in both PDF and CAD from RIDOT. And essentially, we provided 4 different conceptual design figures. You'll will only be submitting one as part of your project. The reason there's 4 is because hopefully covers the major 4 different types of crossings that there could be. So we just need you to choose the one that's most applicable to your crossing. I'll go through each. So this is just your standard open bottom bridge span. And hopefully I think it should cover most of the variables that we care about for hydraulic design and for structural design. So here's the different variables that we call out: your bank full width, and then your minimum span, bank full width at least times 1.2. And then you can update these to be more specific for your project. Obviously, this is very generic. Like I said, it's in CAD. If you want to go crazy and update it or mimic this table and these variables to be everything called out on your own figure, that's fine. But these are the minimum variables that RIDOT needs to see and exchange with your group as you go through with the design. So here's your open bottom span. Here's closed bottom span. So it could be a box culvert, or sorry, not closed bottom span, 3-sided. So this is a 3-sided box culvert or arch culvert. So you could have a box culvert, you could have an arch culvert, and then it's open bottom underneath. Again, it's all the same table hydraulic features. Nothing's changed here besides the actual crossing. And then here's the embedded box culvert. So showing the embedment here as to hopefully meet the base standard at a minimum. Same hydraulic features presented. And then your pipe culvert, and again, showing the embedded culvert, hopefully with banks on either side. And so those are the 4 conceptual designs, and you'll pick one that's most applicable to your crossing and use that for your submission. Next is the final design considerations. So we have construction dewatering, something you want to think about during your design. Make sure it's feasible for the contractor, minimizing impacts to your stream bed, your surrounding environment, and any aquatic animals that might be using that crossing for migration. Thinking about cofferdams and flow diversion guidance for your contractor. And then after construction, we have some general operation and maintenance guidance, the key items to be thinking about, post-construction inspection, and guidance over time. And then Nicole, did you have anything you want to talk about with the cost and scoping? The next slide is just a placeholder for that.
Oh, okay. Yeah, I had spoken with Elisa. We had some questions about, how we're going to start incorporating costs into the tip for this. And I know Elisa meets often with our RIDOT's planning group. And I believe currently right now, when you look through what's in the tip, they're putting in, I think she said around 1 million to any project that we know we're going to have to do some upgrades if it's a replacement. But in the future, there is money available for resiliency. Elisa, I think you know more about that than I do.
Sure. Yeah, that's what I was talking about, the $8 million per year for
Yes, that was
resiliency
it.
funds.
Mhm.
In this new infrastructure bond, that isn't, cast in stone yet or placed in the water yet, but we're certainly going to advocate should we see a crossing that really needs upgrading. We'll be on your side advocating for that funding.
Yeah, so we do know these crossings are going to cost more than what we might be used to in the past, but Nicole and Elisa are doing their best to plan for that and be ready for it. So, as I said, the manual is in effect, and we do have some projects underway. We've just started working with the West River Bridge team in Providence and making sure they understand the manual and have everything they need. And that has led to some minor changes, and that's really just in the checklists and making it really clear and easy for designers to fill out. And then the Round Swamp Bridge in Jamestown is also starting to move through the design process. And so if we have any, hopefully we don't have any updates for that, but we are still working with RIDOT to make sure the manual is clear and understandable for all crossings. So key takeaways from this presentation, I'm hoping everyone is able to go back to their team and tell them, is that the manual is in effect. Everyone has access to it on the RIDOT website, and all upcoming projects will be required to use it. If you have projects currently in design and you don't already know about the manual, then you're not required to use it, as far as I know. The only two streams, or the only two crossings that are required, are that West River Bridge and the Round Swamp crossing. So, second, all new and replacement crossings should aim to meet the optimal standard. And if you are unable to meet it, work with Nicole and Elisa's team to drop down to either base or max extent practicable. And then don't forget to include your checklists in your checklist and your concept design and your report in your 30% design submission. And in a perfect world, all replacement and retrofit projects would first assess the crossing using the assessment handbook, design your new crossing using the design manual, and then go back and assess your new crossing with the assessment handbook and have a before and after for each crossing. That'll definitely help with getting future funding for these crossings by showing, hey, using this manual, we're able to redesign and come up with that much better of a crossing. So that's all I have. I know we're well under our time, but definitely hoping we can have a lot of questions and discussions. I know it's a lot of information and it's all brand new. So now's the time for questions and discussions if anybody wants to get us started.
Yeah, if you have a question or a comment, you can also use the hand raising tool. You can raise your hand and we can get to you. Or if you can leave it in the chat. Yes, can we get a copy of this presentation? Yes, so I will send it out to the attendance list, and also we are planning on putting it on the RIDOT contractors and consultants page as well. So there'll be a link there to the slides. The video will be up there too, so we are recording this.
How about on climate change? Does anyone have questions on that one?
Everyone's in like shell shock right now.
Yeah. How about any feedback? Does anybody have any reactions?
Yeah, any feedback would be great. We had the West River, our consultants fill out the tables for those, and we had some great feedback. So always looking towards improving anything that we have already. Danielle.
Sure. I just had one kind of question, because I know it's stated, obviously, if the project can be optimal, it goes ahead and does that. But early on, we may not know if a project can be optimal or not. So I guess when we are getting these projects and we're proposing stuff, there's a significant amount of design with optimal versus base standards. So just wanted to kind of, I guess, a general thought of how that should be approached early on.
You wouldn't have to, so you would handle this in at around, we'd like to see it at 30%-ish. That's when we're kind of doing a lot of our consultations for NEPA, and we're handing in, starting our permit process, like getting together our consultations to Army Corps and getting together our permit process. So a draft at least would be around 30%, but then a final one probably, and I don't know if Elisa agrees with me, probably wouldn't be more towards around 75% when we're doing permitting. Was that kind of what you were asking when this would be filled out, I guess? Because I know there's a lot of unknowns in the beginning.
Yeah, I think that it was kind of a twofold question. I guess one, are there assumptions? We should just kind of assume early on we're going to try to meet optimal, as much as we can with regard to design assumptions. And then yes, two, with regard to submissions, when is this to be submitted?
Yeah. So, it's almost that the way just the WBS works, you sort of hit it at the 10,000 foot. You're like,
Yeah.
okay, I'm stuck in the middle of the city here. There's really no way I'm going to be able to get to this 1.2 bankful width. The walls are all, already bricked up, or stone, there's all stone walls here. So, there's some things that are going to be kind of obvious at that 10,000 foot level that and then as you get into 30%, which is still a significant amount, but I mean, as you go into the 20 and you're looking at, okay, which of these are reasonable within the budget that we've been given, but, it would really be good to have some kind of passage here, or then you come back and you go, okay, we're not sure this has enough money to do this part of the project. You know what I mean? It's just going to be this kind of circling around,
Yeah.
to get into an answer. Yeah, kind of like with everything.
But I guess would the final report kind of be like when we submit the permits and the stormwater report?
Yeah, all that final stuff. Yeah. But again, if you're making decisions about anything less than the base standard, or you're making decisions about you think you have some decisions you've made about not meeting the optimal standard, we'd like to know about that as soon as possible.
Okay.
So that's what we're talking about in the 30.
Okay. Angela, is this manual applicable to RIDOT bridge projects on municipal roadways? So if it's going through RIDOT and it's a RIDOT project, then yes. I would say even, we're pushing for hopefully the towns see this and they start wanting to use it too outside of RIDOT. But yes, if it's a RIDOT project, then it will be applicable, even if it's a municipal roadway.
Yeah, technically RIDOT owns every bridge over 5 feet in width. So
it should be easy decision because it'll just be going. It's a RIDOT.
But as far as culverts go, I think that's where the big missing gap is on municipal streams, and that's where a lot of the disconnection, aquatic disconnection, is happening. Is on the municipal stream. So we've been talking to the Nature Conservancy, and we'll see what it is we can do to help. But I'm not super encouraged at this point. I think Jody has his hand up.
Yeah, can you hear me okay?
Yeah.
Yeah, thanks for kind of running through this. It's just kind of a lot of information, so I think we're all probably, I'm not sure where to begin. My question is more kind of like process-wise, and it kind of leads kind of from Danielle's point. So from the project management perspective, right now we have sort of the project in scoping. So we have a scoping consultant working on, a lot of our sort of initial work, and they would do the CE, and they would bring it up to, let's say, a 30% level. And then we hand it off to the final consultant to take it from 30 to advertising and construction. So from a process standpoint, do we see this we would probably be identifying this in the scoping phase so that we know, like, the additional design, like if we identify an area, you have a crossing that, I want to say maybe you prioritize certain crossings, obviously maybe more important to you than some others. But in scoping, I assume we would identify it then, so that the final design guy could then have an idea. All right, now this is going to be a major redesign with, we may be going up in elevation. We may now have to reroute 4 utilities that we didn't plan, that kind of thing. Is that kind of how you would see this?
Yeah. So, Anik, can you put up the checklist, at least the existing conditions? Yeah. So we can, definitely have the existing check conditions should be done by 30%. And we'll know at that point what's meeting optimal and what's meeting base standards, if at all. And if they're not, I guess there's nothing in here that says not meeting at all. And that and we'd have to do our best to bring it up at least to the base standards. Yeah. And then at that point, we circle around and we look at it and we go, okay, if we are going to meet the optimal standard on this crossing, then you're right, like utilities or the road will have to get elevated or or the bridge will have to be, widened to the point where there might need to be a midspan, so you definitely, you would go through at those existing conditions and evaluate what you have on site and then start looking at which one of the base or optimal conditions, because I know there's a lot of them out there that don't even meet the base standards. And when we're talking with Army Corps, they're interested in the base standards being met as well. They're going to start asking questions about that. So, I don't know. I don't know if that really answers your question, but
it's going to be challenging because the way that RIDOT works is we just happen to have this new process where we hand it off in the middle of design. So, it'll definitely be a challenge, but we'll have to kind of sort it out as we go along. How far I think what he's asking is how far do we want to get at 30% before we hand it off to our final design consultant?
Well, yeah. So like this checklist, right? So we need it in someone's scope to do the checklist.
Yep.
So this initial run through, we have to make sure project managers know, and Rob, I think, was on the line, but like our planning, the managing engineers are kind of running the scoping, but our initial kickoff meeting with the consultants, we have to know what to include. They're the ones that are going to be analyzing the existing conditions, and what what does it look like compared, and run through this checklist. So what I'm saying is we need to kind of clearly, like whose responsibility is going to be what. And I guess my view is if we identify it in scoping, then that's when, we can get a construction, usually a construction engineer's estimate. So we know, all right, we may need more money in the tip because now, we have some understanding that we may need to adapt this for climate change, let's say.
So what I'm trying to do, Jody, is look at the projects that are coming up before they get to scoping, and see if that needs to happen, if the money needs to get added even to the tip even before, not when it's too late within that fiscal year, but even way ahead. And we'll look at some of the worst ones and point those out. And just like that bridge in Jamestown showed up, on the radar, like, oh yeah, this one, it's obvious this one's going to need some significant upgrades to meet any kind of standards. It's in a dangerous situation right now in terms of climate change, being flooded on a regular basis. Yeah. So there's severe restrictions there. So there's been like $1 million that's been added to the tip just for this project already. So yeah, it should start almost sooner or before. And so we are going to hire a consultant this summer to go out and start at least with the assessment on some of these and see if we can get ahead of it even before then.
But I mean, as part of that initial scoping engineer's project, wouldn't he have to fill out this information or no?
Well, yeah, it could partially be filled out already, could be.
Yeah, so we could have identified it as, hey, this is going to be a critical thing, but they're still going to, the first guy that we bring aboard, they're going to have to kind of run through the checklist and the manual as part of the design process, I'm assuming, right?
Yeah,
yeah,
and
that's what I pictured. Yeah.
Yeah, that's correct, Jody.
Yep. Okay, Bob. In many cases, there are downstream issues that may arise with the larger culverts, openness, etc. If we don't have scope or money to analyze downstream issues, would smaller culverts that work hydraulically for the design storm be acceptable?
It's kind of like a two-facet question.
Yeah.
In a perfect world where we have the scope and money, we would do an unsteady analysis that we could hopefully provide a larger culvert that could provide the openness without and confirm that we don't cause downstream issues. But as we're discussing, there's going to be scope and money issues. So in that case, there might be a situation, yes, that you'll have to accept a smaller culvert in order to make the project happen and provide a safer, updated crossing.
Also,
Nicole,
in a perfect
do you agree
world,
with that? Yeah.
and also in a perfect world, we'd want to move from the downstream towards the upstream in terms of opening up
I agree.
and not causing the flooding. You're right. Some of these streams, in the way the culverts act, they definitely buffer flooding. So
Yeah.
Did I answer your question, Bob?
Yes, thank you.
Did we get to Danielle's question already?
I think we did. Dale, you still have your hand raised. I'm not sure if you had another question.
Oh, I'm not sure how to unraise it. Sorry.
Okay, I can unraise it for you. It's okay.
Thank you.
You're welcome. There you go. Anyone else? Nope. Okay, Jody.
I had one more question. So if we have a project where we're paving over a culvert and it, like just a paving project, let's say, and the work, that paving may trigger a wetlands or Army Corps permit, but we weren't planning on replacing the culvert or bridge because sometimes RIDOT separates those. How is that handled in this case? Like, does just doing paving now trigger you into having to do a full analysis, hydraulic analysis of a culvert?
No. This was really made just for if we have a bridge, a specific bridge project, it's going to be a replacement. I would say, at least I don't know if you're on the same page, but I would say even if it's just a rehab and it was always going to just be a rehab, we wouldn't be using this to do any, to redesign the crossing, because it's not being replaced. Again, in an ideal world, if we had an assessment done and we knew it was in very poor condition, very undersized, then you would see that in the tip already, and we'd put in money and it'd change from a rehab to, say, a replacement.
Right, it would be the rehab or it would be paving and a culvert replacement. So, Isam has said over and over again, for the project managers, if there's time and money, whatever the scope is, the scope is. So if we identify this or that early on, that this is definitely a culvert that needs to be replaced, just like it's happening in Airport Road, like that's part of the project. And so there's going to be some repaving, but there's a, giant culvert that's either going to need to be lined or replaced for, because it's structurally unsound. So that if there's something that just severely doesn't meet aquatic passage or doesn't meet climate change and resiliency standards, we'll pick the worst of the worst that need to be better, but it should come to you as part of the scope.
Yeah, it wouldn't have to be triggered, by a repaving project or anything like that. Even if you're, impacting wetlands, because this is separate from state wetland permitting.
I was just wondering more like Army Corps, like we mentioned, Army Corps maybe.
It'd have to be part of the project. Like if you're filling in some biological wetland for some reason nearby or impacting it, and you're, applying for a permit, this wouldn't really apply, even if there's a bridge somewhere, underneath.
I think what she's saying, Jody, is you have to be working on that structure for the
yeah. Okay. They're not going to randomly bring up, hey, why aren't you replacing this? It's undersized.
Right, that one 5 miles up the road. Yeah, no, they're not going to do that. Yeah.
It gets tricky because like when we do the paving project, now we may be improving, doing some kind of drainage and swale work, and certain times that drainage may discharge into that culvert area. It gets kind of intertwined a bit.
And that's the beauty of it all. That's why I always liked water. It's always moving. It's not the same. It's not a bridge. It doesn't stay in one place. It's definitely a big puzzle challenge. So, yep, that's why
this manual in particular in the Army Corps, the new Army Corps permit coming out, it is only recommended to be used on particular GPs. So if it's a general permit that's related to a stream crossing, because there is a stream crossing general permit, that's where it's mentioned. So if you're applying under the GP for a stream crossing, then yeah, you would want to look at this. But a resurfacing project or fixing a swale, that wouldn't fall under that GP. So you have to go back and look at the permit too and where that falls. If that makes any sense. You have to be familiar with the Army Corps permit.
Oh, Angela, that's a good question. Existing municipal culvert that's less than 5 feet wide is reconstruction per the guidelines. Will the structure be now owned by RIDOT? That's very possible. And that would be something
Yeah.
that I don't think they would appreciate very much. So I'll have to talk to them about that.
Yeah, I guess when that comes up, I guess we'll talk about it.
Yeah. Just make sure you design it to 4 foot 9, 11 and a half inches.
All right, is there anything else? And if anyone thinks of anything after too, you can always reach out to us with any questions.
Yeah, so there's our contact info there. The manual is available on the website right now, as we said. There will be some very minor updates over the next week and a half, 2 weeks, just to the final checklists. And otherwise, we got you about an hour back in your day. So thank you all for coming. Please reach out with any questions as they come up.
Yeah, thank you, everyone.
Thank
Hope
you.
this was
Thank you.
helpful.
Great job, everyone.
Nicely done. Thank you.
Thank you.
Thank you.
Nicole, there was a few items I wanted to catch up
Yeah.
with you guys on. You
I
want to
figured,
do
so I was
a
staying on.
separate call? Since this one's being